Hello, my name is Keshwani. That's Keshwani, Keshwani. We are here because we want to prepare for SAT. We have been solving SAT math problems out of this book here, the official SAT study guide. If you do not own this book already, purchase one immediately. You're going to need it. The problem that we are about to solve is the one that you will find on page number 597. Please turn to it, page 597, and today is our lesson number 54. Let's see what we have here. We are doing the problems that you find in the second column of this page. Yesterday we did the problems that you find in the first column. So today we're going to start with number 14. In problem number 14 we are told it is important that you have the book in front of you and that you read the problem on your own. We are told that the first term in the sequence above is A. Alright, so the first term is A. Each term after the first term is 3 times the preceding terms. Alright, so the next one is going to be 3 times A. The one after that is going to be 3 times 3A, which is going to be 9A. One after that is going to be 3 times 9A. Oh, better yet if you like. It's going to be 3 times 3A. The one after that is going to be 3 times 9A. The one after that is going to be 3 times 27A, and so on and so forth. What is the question asking? If the sum of the first 5 terms is 605, what's the value of A? Alright, so we have 5 terms on the blackboard. Right here are 5 terms. We have A right here, we have 3A, then we have 9A. Let's do them here. A, 3A, 9A, then we have 27A, and then we have 81A. Let's add them all up and see what we get. How many A's do we get? Well, let's see. 3 plus 27 is going to be 30, and 9 plus 81 is going to be 90. 90 plus 30 is 120. I get 120, and then we have one over here on the top. Right, here's one here on the top. So 121A. One more time. Okay, so don't reach for the calculator for every single bloody thing. Do you understand? Use your brain a little bit. So 3 plus 27 I see here. 3 plus 27 will be a now nice round number of 30. Then I see a 9 and an 81. 9 and 81 would add up to a nice round number of 90. 90 plus 30 is 120. Plus 1A to begin with, 121A. And we are told that 121A equals 605. The question simply is, what's the value of 5? So all we have to figure out is how many 621 into 605. Let's find out. 121, well, 121 times 4, there will be no point in doing it into 4 because that will give us 480 something. You see, 4 times 20 would be 80, and 100 times 4 is 400, so it's going to get 480 something. We need to get close to 605. Let's try 5. 5 ones are 5. 2 times 5 is 10, we carry 1, and there we go, 605. 605. That tells us, this implies that A must equal 605 divided by 121, which is 5. The value of A is 5. And that's all. That's it. Next one, shall we? Number 15. Number 15. Number 15 is a little bit nasty. We'll see what we can do. We're given 2 triangles. P, Q, R. P, S, R. Oh, sorry, I left out something. Oh, I made a banged up job, didn't I? I did a really banged up job here. This doesn't go all the way there. It comes out this way somewhere here. This is the T, and this is V. Alright, so far so good, and we are told that this line Q to V, we are dropping a perpendicular, sitting at 90 degrees, which is very important here. Let's see what they tell us. In the triangle PQR above, QS over QV equals 1 over 3. In other words, what they just told us is that the ratio of QS to QV is 1 to 3. If Q to S is 1 unit, if Q to S is 1 inch, for example, if Q to S is 1, Q to S is 1, then Q to V has to be 3 inches because the ratio is 1 to 3. So if Q to S is 1 and Q to V is 3, then S to V must be 2. Voila. That's the first bit of information they give us. Second bit of information that they give us is the fact that P to T over P to R are in the ratio of 3 to 4. Let's see what we can do. If P to T is 3 units, then P to R we are told is 4 units. So if P to T is 3, P to 3 is 3, then we are told that P to R is 4. P to R is 4. P to R we are told is 4, which means this part must be 1. T to R must be 1. And that's it. That's enough information that we have here, because what they're asking here is the ratio of the two triangles. I'm going to erase this part, we're done with it. You're looking for the ratio of the two triangles, ratio of the areas of the two triangles, and we're going to calculate them separately. First, let's find the area of triangle PST. How do we find the area of a triangle? The area of a triangle is simply 1/2 base times height. 1/2 base PST. PST. Let me put it in a different color so we can see it actually. This is what we're talking about. PST. What's the base? What's the base of this triangle? P to T. P to T is 3. So that's the base. And what's the height of this triangle? The height of the triangle is from here to here, which is 2. So that's it. The area of PST is just 3 because 2 drop out. The area of PST is 3. Let's find the area of the triangle PQR. Area of triangle PQR, again it's going to be 1/2 base. Now let's look at the PQR. PQR is a large triangle, the outside triangle, and we know that P to T is 3, T to R is 1, which means the base is P to R. P to R is P to T plus T to R, which is simply 3 plus 1, which means the base of this triangle is 4, times the height. The height is all the way from V to Q, which is 1 plus 2, which is 3. So again, the 2 drops out and we end up with 6. We're almost done, and therefore the ratios of the two triangles, which one goes on the top? PST goes on the top, PQR goes on the bottom. That's exactly how we have. So the ratio of the two triangles is going to be, see, this is 2 times 3 and that is 3. So that's very straightforward. So the ratio is going to be 3 over 2 times 3. That's it. Ratio is going to be 3 over 2 times 3. 3's drop out and the answer is 1/2. Again, since this is a grade-in question, you can grade in 1/2 like that, or you can grade in 0.5. I prefer to keep it in fraction. Just keep it in fraction. 1/2 is simpler to do. That's it. We're done with this one. Number 16. Let's see what they ask in number 16. That's it. We're done with this thing. I'll give you a second. In number 16, they're giving us a function which looks something like this. H of x, we are told, equals 14 plus x squared over 4. We are told that h of 2m equals 9m. Question is, what's the value of m? Well, h of 2m is same as saying what's the value of the function when the independent variable equals 2m. So wherever we see x, we replace it with 2m. Again, as I've told you many times in the past, and I hope you're watching these videos in proper sequence from day 1 through day 54. Don't skip around, because I assume, I take it for granted that whatever I've covered before, that you know it already. In one of the past videos, not one of the past videos, but in a few past videos, I have mentioned the fact that if you are weak in the concept of function, if you haven't quite grasped what it means to be a function, just type in this thing here. Just type in, what is a function? Just type in this tag, what is a function, along with my name, Keshwani, and out will pop. I can't say it properly. What you will see there is a video dealing with the concept of function. Watch that video and you will understand it better. So this is same as saying, what's the value of this function when x equals, see, h of 2m is same as saying, what is the value of this function that is given to us, this function, when x equals 2m. All we have to do is, wherever we see x, we replace it with 2m. Let's do it. So h of 2m is simply 14 plus, we replace, wherever we see x, we replace it with 2m over 4, which is going to be same as 14 plus 4m over 4. 4s are going to cancel out, and it's going to be 14 plus m. 14 plus m. But then they go on to tell us, that it equals to 9m. This should have been m squared. Then they go on to tell us, actually this is a little bit more complicated problem than actually I thought. I thought it was going to be a linear equation, because I was looking at m, it's actually m squared. This is going to turn into a quadratic equation. We're going to have to solve a quadratic equation by using a process called factorization. This is a little bit more involved than I thought. And this quantity, we are told, equals 9m. Because we were told in the beginning that h of 2m equals 9m, and therefore this quantity equals 9m. Let's bring the 9m to that side, so we end up with m squared minus 9m plus 14 equals 0. I'm going to pick this up from the top here. M squared minus 9m plus 14 equals 0. So now we are looking for two numbers. Now we are looking for two numbers whose product equals positive 14 and whose difference, whose sum rather, equals negative 9. I'm going to erase all of this thing, okay? We don't need this anymore. Or we can keep it. Can you think of two such numbers? That's the tricky part. You have to think of two numbers so that when we add them, we get negative 9, but when we multiply them, we get a positive 14. Pause the video if you have to and see if you can think of two such numbers. One more time. We're looking for two numbers which, when we add them, we get negative 9, and when we multiply them, we get positive 14. And the two numbers are negative 2 and a negative 7. Negative 7 and a negative 2 add up to negative 9, and negative 2 times a negative 7 gives us positive 14, which is this part right here. Which means we can break the 9m into negative 7m and a negative 2m. Let's do it here. So m squared minus 7m minus 2m plus 14 equals 0. This is called this process that we are about to embark on is called factorization. And again, if you're not familiar with this concept, or if you're weak at it, just type in factorization along with my name, and something you will find a whole bunch of videos, about 10 of them, dealing with the concept of factorization. What you have to realize is that I have close to 1500 videos by now. I am sure there is a video on just about every concept that you will, well, I shouldn't make such a bold statement. There are videos on quite a few concepts that you will encounter on the SAT, that you're likely to encounter on the SAT. Factorization is one of them. This is called factorization. So that's it. So negative 7m and a negative 2m gives us back our negative 9m, and negative 7m times the negative 2m is going to give us our positive 14m squared. Look at this term and tell me if you find something common. What do we find in these two? What do we find common in these two terms? The common factor is m. We take out the m and we get m minus 7. You can see m times m is going to give us back our m squared, and m times negative 7 is going to give us our negative 7m. Now we look at these two here. This guy right here and this guy here. Do we find anything common in them? A negative 2 and a positive 14? What's the factor that we find common between negative 2 and a positive 14? And the common factor is negative 2. If we take out negative 2, here we are left with m, because you can see negative 2 times m is going to give us back our negative 2m. And if we take out negative 2, 14 divided by negative 2 equals what? 14 divided by negative 2 equals negative 7. So that goes here, because negative 2 times negative 7 is going to give us back our positive 14. And then we look at this part and this part. I realize that in the US you're not taught all of these steps. You're just expected to memorize the bloody thing and just throw it in there. That is not how I was raised. You show all the steps, you show all the work. You understand? So what do we find common in this term and this term now? M times m minus 7 and negative 2 times m minus 7. The common factor is m minus 7. Let's take it out. M minus 7. Once we take out m minus 7, from here we are left with m, and from here we are left with negative 2. And we are told that that equals 0. If the product of two quantities is 0, then this implies that either m minus 7 is equal to 0 or m minus 2 is equal to 0. One of them has to be equal to 0. One of these two quantities has to be equal to 0. If you have two quantities and the product of those two quantities is 0, then at least one of those two quantities has to be 0. Maybe they are both 0. Either m minus 7 has to be 0 or m minus 2 has to be 0. If m minus 7 is equal to 0, that would imply that m is equal to positive 7. If m minus 2 is equal to 0, that will imply that m is 2. There are two right answers here. In grading questions, many a times you run into a scenario where there are more than one right answer. There are sometimes 50 right answers. Your job is simply to grade in one possible answer. So here they're asking us what is one possible value of m, and the answer is one possible value of m is either 7 or 2. It's up to you. You can grade in either and you will get the credit for it. Do you understand? Like yesterday we found in the previous column, number 13, problem number 13 in yesterday's video, we found that the possible answers for number 13, question number 13 were 13, 14, 15, 16, 17. There were 5 possible answers. Just grade in any one of those 5 answers and you will get the credit. Here there are 2 answer choices, 2 and 7. Pick one and be merry. Do you understand? It's okay to say be merry, but for some inexplicable reason it's not okay to say be merry with a synonym beginning with a G. I don't know why, but that's how it is in the US. I will see you tomorrow. Okay? Bye now. Not that there is anything wrong with it, you understand? It just sounds weird. In the British English it would have been okay. Not in the US, not the American English. Be merry, be happy. Pick one and be merry and go on with your life. I will see you tomorrow, okay? Bye now.